Okay, so now let's move from nets to surface area of nets. The total surface area is the covering of the area of all faces. So for instance, in this crayon box I have right here, if we're talking about the surface area, we want to talk about the area of every one of the faces added together. Okay? So the total surface area is the covering of the area of all faces, including the bases. Within a net, there can be congruent figures which are the same size and shape. So let's take a look at these nets right here. Here we have our triangular prism. Let's look at the ones that are the same, and we're going to color them the same color. So this rectangle right here is going to be the same as this rectangle and this rectangle. And the way I knew that is this triangle is marked with these three lines, which they have the same line on each edge, and that means that all those edges are equivalent. So that makes your rectangles all equivalent to each other. So we're going to color those all the same color. Okay. And then the two end faces, the triangles, are the same. Okay, they're the same because if the rectangles are all the same, then the triangles are going to be the same too. And when we have these lines marked like this on all of them on the same figure, then they're equivalent with each other. Okay, so let's take a look at this next one. This is our rectangular prism. Okay, when we take a look at it, if we look at this rectangle right here, and this rectangle right here, they're going to be the same. Okay. Then if we take a look at this rectangle right here, and this rectangle right here, they're going to be the same. Okay, so let's pretend this crayon box is that rectangular prism. So the two blue ones would be the top and the bottom, whereas the two red ones would be the front and the back. Okay, and then we're going to take and color these two that are on the end the same because they're equal. And they would be like the two on the ends. Okay, the opposite faces are going to be the same. Okay, so let's take a look at this triangular pyramid because it has the base right here in the center of a triangle with all the edges the same. And guys, that means all of these edges are going to be exactly the same. So that means that whole triangle, every single one of them are equal to each other. So the whole thing is going to be shaded the same color because every one of these faces are equivalent to each other. Okay, so when we're finding the surface area of these, what we can do is we can find the area of the one face and then multiply it by ever how many times we have that one there. Okay, so let's look at number one. If we decompose each net into different congruent figures, then find the area of each figure. Okay, so let's take a look right here. We've got our first one right here. And it matches this one right here. So those are both rectangles. So we've got our formula area equals base times height. And I had somebody ask me, can you use length times width there? Yes, you can. But since most everything we've got uses base times height, I'm going to use that. But we're going to put in our values. So our values there are 8 and 6. So we've got 8 meters times our 6 meters. And 8 times 6 is 48. And that's 48 meters squared. But there's two of those. So we need to multiply that times 2, and that's going to be 96 meters squared. So for the first one, we've got 96 meters squared because we're going to add all this up, okay? So then for our second one, let's take a look at it. It's right here. And this one right here is going to match it because when we fold it up, they would be opposites, okay? Okay, so again, we're going to use our area equals base times height. And we're going to plug in those measurements. It's 15 right here times this measurement right here, which is parallel with this one. So that's going to be this same measurement here, which is 8 meters. And when we multiply that, 15 times 8 is 120. And that's meters times meters is meters squared. And 120 times 2 is 240 meters squared. So we're going to add that right here. Okay, and then shape 3 would be this last rectangle. Okay, and we need to figure out the measurements there. So when we look at it, this measurement right here is what we need, and that's parallel to that one, so it's going to be 15 meters. Our formula again is area is base times height. So we've got our 15 meters times, and we've got to do this measurement. So that's where we've got to think about what measurement does that match up to when we fold it. When we fold it, it's going to match up to this one right here, which is our 6 meters. So 15 meters times 6 meters is 90 meters squared. And we multiply that times 2, and that's 180 meters squared. So we add that here, 180 meters squared. And then we need to add all of that up together. And that added up together is 516 meters squared. Okay, so we just do the each individual one, see how many times it's there, and then we add it all up together. Okay, what pattern do you notice when finding the total surface area of the rectangular prism? I noticed that they were 3 different rectangles, or 3 different size rectangles. And so you can find the area of these, find the area of each. And multiply by 2. Since each one of them is there twice. Okay, and then add all together for the area for the surface area. Okay. The B says if the net above was a triangular prism, what would change about the process? Okay, what would change about the process is that we would have 2 triangles for the bases and 3 rectangles for the faces. Okay, so in that case, we would have to find the area for the triangles, multiply by 2, and then that is a 3, even though it doesn't look like it, 3 rectangles and multiply that by 3. Okay, so area of the 2 triangles plus the area of the 3 rectangles. Okay, so that's how we would find that. Okay, so let's look at the back. And this one, we have a surface area, in this case, of a triangular prism, because each of the bases are triangles, and then you have your 3 rectangles. So we have 2 triangles that are the same, and 3 rectangles that are the same. Okay, so our first one, let's find the area of the rectangle. We've got base times height. Okay, so we've got 3 rectangles that are the same. So we've got 8 centimeters here times 18 centimeters. Okay, and that equals 144 centimeters squared, and we need to multiply that by 3. Okay, so 144 times 3, let me grab my calculator here. 144 times 3 equals 432 centimeters squared. So we've got 432 centimeters squared for the rectangles, plus we need to add the triangles. So we've got triangles, we've got area equals base times height divided by 2. So we've got our base, which is our 8 centimeters right here. And our height, remember, is where it forms the right angle from the top of the triangle down to the base. So that would be our 7 centimeters divided by 2. Okay, and 8 times 7 is 56. Divided by 2 is 28. And then we need to multiply that back by 2 and we get our 56. So we've got 56 centimeters squared here. And when we add all that together, we get 488 centimeters squared for the surface area there. And there wasn't a shape 3, so we don't need anything over there. Okay? So when you look at it, you think about all the shapes, you find the area of each one, and then add them together for the surface area. Okay, so let's take a look at this last one. At the this is a rectangular pyramid because it's got a rectangular base, 4 inches here and 6 inches here. So our first shape is our rectangle, base times height. And that is our 4 inches times our 6 inches, which is our 24 inches squared. That's only there one time, so we're going to go ahead and just put it down here. Okay, and then we have 2 different size triangles, so we're going to have to find those there, and there's 2 of each one. So the first one, area equals base times height divided by 2, and we've got our 4 for our base right here and our 7 for our height right here. 4 inches times 7 inches divided by 2, and that's 28 inches squared divided by 2, which is 14 inches squared. And then we're going to multiply back by 2, which is our 28 inches squared, because this triangle and this triangle are the same, so we need to multiply it by 2. So we're going to add our 28 inches squared here. And then our last one, we're going to look at this triangle right here and this one here. So we are again using area equals base times height divided by 2. So we've got our base, which is this line right here, which is the same as this one, which is 6 inches, times our 6 inches for our height right here, divided by 2. And that's 36 inches squared divided by 2, which is 18 inches squared. And then multiply that back by 2, gives us back to our 36 inches squared. So we're going to add our 36 inches squared here, and when we add all those up together, we get 88 inches squared. Okay, now let's look at the last one, down here, last two actually, down here at the bottom, we've got the surface area of a cube that is 150 inches squared. What is the length of the sides of the cube? Okay, so we've got 150 inches squared there, and that means we've got 1, 2, 3, 4, 5, 6 faces, so we've got 150 inches squared, and we know that each of those 6 faces has the same area, so we're going to divide by 6. Okay, so 150, 150 divided by 6 equals 25 inches squared. Okay, so that means each one of these is 25 inches squared. And the reason I divided them by 6 is because the area is all the same, because it's a cube and each face is the same. Now, if this is 25 inches squared, we need to find the side measurements, okay? The side measurements. That means each side is the same, so what times itself equals 25? And guys, that is 5, because 5 times 5 is 25, so each side length would be 5 inches on that one, okay? That's where you had to kind of work backwards there, okay? So now let's take a look at this next one, the surface area of the triangular pyramid. Okay, we've got a base that measures 10 meters and it's 8 and 6/10 meters tall. And guys, if we look at this, this is 10 and this is 10, so these are all equal. So these are all equal lateral triangles. So we need to find the area of the equilateral triangles and of one equilateral triangle and then multiply it by 4, because there are 4 there. So we've got area equals base times height divided by 2. Our base is 10 meters times our height is 6 and 8/10 meters divided by 2. 10 times 6 and 8/10 is 68, because when we multiply by that 10, we move that decimal one place, divided by 2, which is 34 meters squared for each triangle. But remember, we said we have 4 triangles. So we're going to go over here, and we're going to multiply that 34 meters squared times 4, because there are 4 of them. And that equals 172 meters squared. Okay? Now, like I said, if you have any trouble, contact us and we'll be glad to work through it with you.